The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont and Lou Atori from our nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, June 5th, 2025. We have just seen episode 24 of Kilauea's eruption start last night and end this morning. So that'll be the main topic of our update today. How are you gentlemen doing today? And how's your last week been?
Doing good. Yeah, we're just anticipating this last episode, and it surely did not disappoint with the spectacle that it put on for us. So yeah, excited about that. And we'll go through that latest episode here. And how you doing, Lou?
I'm doing good. Same with you. You know, this last episode was unique in itself, right? We saw some different things happening that we haven't in the past, and caught us kind of off guard last night. It snuck up. I went to bed, not thinking we were going to have anything last night, and
I mean, you went to bed. I was, I was saying like yesterday. Oh, I think it's tonight. Anyways,
Yeah.
Back to you, Phil.
Yeah, for sure. Yeah, and we're seeing them be shorter. So yeah, if you didn't catch it last night or early this morning, then by the time you woke up, it was probably all done. So interesting, those patterns, and yeah, we'll get into it here in a bit. So as usual, Dan will be leading discussion in chat. Lou helping as well in the back end, and we'll be going through our regular paces today. Anything else you guys want to add before we get into it?
Oh, I think we're good.
All right, so let's switch our screen. And let's see. All right. Hello, everyone. This is our Hawaiian Volcano Summary for June 5th, 2025. Kīlauea Summit Eruption has made its 24th episode that began last night, June 4th, and ended this morning, June 5th, after about 7.5 hours of fountaining. The fountains all remain within the crater, although they are building some accumulation of tephra on that southwest rim, which is visible in some of these camera views. These are time-lapse images of the live streams from the USGS, showing lava coming out from the north vent first, and then adding to the south vent as well, with those initial high fountains greatly exceeding the height of the crater wall behind it, and feeding massive flows within its western part of the crater and building an edifice within the western part of the crater itself. The gas cloud was ejected into the air up to 16,500 feet or 5,000 meters, and that largely kept the impact of VOG away from people on the ground, although there does seem to be some impact, as we'll see here in just a minute. What you can see here is that shut off of the north vent, then the south vent, visible from the various cameras, following the overflow that began last evening. So the USGS has now noted the times and ends, as well as durations of fountainings, and an estimated volume of 5 million cubic meters for this latest episode, following a pattern of the previous ones listed here. All this still happening in the southwest part of Halemaʻumaʻu crater within the greater caldera of Kīlauea, within a national park, and posing no additional threat to people. Largely, it's the VOG and the fallout, which are impactful and restricted to the closed areas of the national park at present. Following the collapse of following the deflationary part of the tilt here that accompanied episode 24, we've seen the beginnings of inflation coming back up. So it does appear that we are in for another episode after another recovery phase of the volcano refilling with magma underground. The USGS says it's too early to predict another time window quite yet, but considering the drop in ground tilt that we've seen in 24 being similar to 23, we should expect a similar pause of about 10 days, which is what preceded this most recent episode. And that's what they show in their analysis in today's daily update right there. So the VOG dashboard is showing fairly limited emissions at lower levels, and those emissions being carried to the southwest, affecting the typical areas nearby and downwind of Kīlauea. But we can look at a freshly in satellite capture of SO2 in the full atmosphere that's showing quite a lot of this gas in abundance over both sides of the island, and in fact drifting to the north as well. So that does suggest that the upper atmosphere is involved in dispersing those winds, because our citizen science monitoring network is showing fairly limited impacts on the ground. There are some, but they're limited. Otherwise, earthquakes have been quiet over the past week, following the same pattern as we've seen since the beginning of this eruption in late December 2024. There are a few earthquakes underneath Kīlauea caldera, with some adjustments happening there, as well as Kilauea's south flank, and the feeder zone from the Pahala hotspot. So these are all within background ranges and actually a little bit lower than we're used to seeing. Because as eruption is offering a relief for any of the pressure building underground from magma, the volcano is moving a little bit less than it typically does. We can see here in our north-south GPS across the summit caldera that we are oscillating across an slowly spreading center, although that rate is quite a bit slower than we've seen in previous parts of the year, leading to other eruptions on Kīlauea. On the Middle East rift by Pu'o'o, closer to people, we still see contraction of the rift and a little bit more noise in the data due to some local adjustments and settling most likely, but still showing no sign of magma intrusion as was the case in the middle of last year. That's it on Kīlauea. Mauna Loa is still quiet as usual. Here the whole last month of earthquakes showing a smattering of events underneath the summit and under the west flank as well, but well within normal levels that we've seen here at earthquakes per month over the last 5 years. You can see the rates are maybe growing slightly, but they're still well within this background rate and nothing near the levels we saw in the years of buildup ahead of Mauna Loa's eruption in 2022. Still, the caldera appears to be rising, as shown by the GPS, showing the mountain is still filling with magma and swelling in preparation for its next eruption, whenever that may come. And that's our Hawaiian Volcano summary for this week. Okay, so let's move on to our volcanic hazard summary. And let's start off here with this video that's showing just the S2 camera in the daytime over the past week since the last episode ended. This is showing how the gas is blowing from the center to the left of the screen here for the most part. And yeah, it doesn't really change across much of the week. You see it at the start of that animation and at the end, a little bit of this flow of this hillside here in the daytime views of following each of these episodes. So that's pretty good. We have the summer pattern of trade winds. But as I said earlier in our summary just a few minutes ago, we just have this most recent image just released and just come in here showing this. It's a little bit cut off by a satellite pass, you can tell here and here. Right? But you can see there's a massive amount of gas in the air. So we can rewind to our previous episodes. This is a little bit of the low-level activity with southwest flow. You can see there a little bit sticking around the summit and coming back in time to there is one of our previous ones where we had another injection into the atmosphere and it was heading to the south. The other ones we've had have been actually closer to the ground level and affected the island, the saddle to the northwest, other islands as well. Let's see if I can go back in time far enough to find one of these in here. Having them not all be loaded already, but yeah, for example, that one right there. Right? So as you can see, there's still quite a lot of gas coming out. It's just a little bit different dynamic, and it could be helping us that it's shooting into the atmosphere so high, those 5,000 meters, 16,500 feet or so. Maybe that's limiting the impact coming down. So you can see that a little more easily in that time-lapse animation. We'll point that out here in a little bit. But looking at the windy.com, which is a similar satellite view, there it's showing that extra little blip right there, and we are in our own little patch of sulfur that's swirling around the atmosphere around our island here. Since we've done this 24 times now over the last 5+ months. So looking at the VMAP project, that's the VOG Measurement and Prediction Project out of University of Hawaii in Manoa. They offer this VOG forecast dashboard that we have set to the more raw SO2, which is how it is closer to the source. And with this emission rate of 1,500 tons per day, which is this background inter-episode average, like we're in right now, you expect to have the gases swirling as such, right? That's not to mention anything that might have been produced earlier in the morning and actually caught in the trades and maybe blown into this area as well. So there could be higher concentrations than indicated on this map right here. This is just plain SO2. Let's go to SO4, where you have a little bit more of that reaction product of the gas as it flies through the atmosphere and reacts with water vapor, and it's aided by the sun and all of that. So you can see a little bit further effect into South Kona over here and over Mauna Loa into the saddle a little bit as well. But even here, I would expect that there might be some extra effects from some of this material. And not only that, it's not quite clear if any of that stuff that's higher up can come back down. I'm not really a meteorologist, but it seems unlikely you'll have very much of it. But if we do go to our interactive maps, here is the state of Hawaii map, Department of Health. Everything looks to be in the green with a few slightly elevated readings, but still in the green. So back to purple air, and to look in a little more detail at some of these readings, you can see, let's go here to the saddle. And when we click any one of these stations, we can see this little graph here that goes back June 3rd, June 4th, June 5th. And so we're getting more than 48 hours here. And this is showing you that just today that this reading can go up. So that could be something localized during the daytime in a saddle, like a dust storm or some, exercise kicking up dust, or possibly the VOG itself, if it's coming down, actually just reaching this area only today, only this morning. In any case, you can see there's some kind of weather effect happening there. We can go to some other stations. Let's pull in, for example, Pahala. Pahala, right there. Not sure how big this is going to look. Maybe I can try to make it artificially bigger here. All right. So there's two sensors at Pahala. This is showing how one of them here is climbing up in the afternoon yesterday, and then hits a greater peak, and then comes back down here. So that one possibly could be related to the timing of our episode. But some of the other sensors, like this other one here, are not quite showing quite that same pattern. And in fact, let's see if I can zoom this out without messing up. All right. Some of these other ones we can superimpose on here as well. So let's add on, let's see, maybe that was not a good one. That was still coming. All right, didn't really change much of our graph over there, but here, let's add one of these ones in Ocean View, where we have an actual reading that's not zero. And let's see how that looks in comparison. So there's our blue Pahala signal. And some of these other stations are also just showing some of this material coming in this morning. So it may be that because much of that stuff blew into the atmosphere, that we're dealing with it just coming in the morning today. And maybe what I'll do here is just come back to this video that we have and just come to this very last part of it right here. And so this is a KP camera on the side of Mauna Loa looking to the south. This eruption is starting at night. Here we are at 9 p.m. And so there it goes, it starts. And I'll pause it very quickly. The gas cloud is coming up and hitting this upper level. And this upper level you can see is starting to blow it, in this case, towards the camera a little bit. But then continuing, you can still see it's coming up and mushrooming out into this upper atmosphere still here. And then come just before dawn here, right? So 4:25 as eruption ends, and there's less of that perhaps thermal updraft. You see this top turn over, and now it's blowing over, further hugging the ground. So you see some other material blowing in here as well, from kind of swirling from the side, but I'll play it again from the start, because this is perhaps the interesting thing that our meteorologist friends can chime in to help us out. It looks like it starts off kind of low, and then a lot of it gets pumped into the upper atmosphere here during eruption. Then as it ends up falling back to the ground, and any effects happening this morning might have been from this trailing cloud and plume you see right there. So pretty interesting to see that, and that's what we can share with the gas today. Just checking in as another data point here to the National Park Air Quality Alert site, Hawaiian Volcanoes National Park. And everything is in the green currently, but we can come back to the charts and look for the last 24 hours. You can see that all the stations that are recording are all in a green, and not a single one of them recorded reading out of the normal range of green. So that also seems to support that. Perhaps because it was at night with fairly weak winds that allowed that gas cloud to rise higher up. All in all, that seems to be the effect, is pretty limited down on the ground, at least where people can actually get. We'll see in a bit here in our next segment, it's going to be our observations on Kīlauea, that back rim of the crater does change in shape a little bit. So we'll look at that here coming up next. But starting off our observations, we're going to use this USGS photo release from the May 28th and 29th, after 23 and before 24, just showing how they're out there using GPS to measure the new elevation of the tephra. And they have these stakes that they stick in the ground that are taped off every, looks like 10 centimeters or so they can come back and measure how much more burial has happened since the last time. They have stuff falling in these buckets that they collect, and then they empty the bucket, and they can use the stuff that's in the bucket for their samples for this episode, right? And that's basically that's what they're doing there. They're having to drive across lots of this tephra to get around, and they note that from this angle they can see here this hill that's growing. This is from episode 23 already. This new hill growing on the southwest rim of the caldera. Here they estimate it to be roughly 10 to 12 meters or 33 to 39 feet thick. And this looks like a little hill here, but almost 40 feet thick potentially on the rim there. So we'll come back to that a little further ahead. But then we also have this close-in view of a piece of reticulite, some of these higher fountain products of lava, different shapes of tephra here. So very frothy, it's so thin, bubble walls are so thin, the color of the tephra is more of a golden brown. So awesome photographs by Elizabeth Smither there. Here's another aerial view. Now we're catching the southwest part of the crater itself. And then starting up here, this lighter gray stuff is the old lava flows. You have a little bit of the outer caldera fault right there. There's a little bit of a scarp as well. But you see this blanket of brown stuff, that's the new material that's been falling off in this direction. And so that hill that's growing is often here on this side and further a little bit off the picture to the north as well. It's hard to see here. I maybe can see a little bit of a remnant of that June 2023 eruption, but it looks like it's getting pretty well covered if it's not just some other discolored bump by now. I think that thing is probably all the way dead, buried all the way. Let's see, maybe this image will show us here. So looking to the south, that same kind of view, and let's open it to the original here and come all the way in. And yeah, it looks like it's fully all the way buried now. It looks like just slabs of these chaotic flow that's coming off of this growing spatter and cinder cone over here in the southwest part of the crater. So yeah, there it is. Here's this right behind the gas cloud, and the dark part is where all this tephra is accumulating. You can maybe see how this little scarp of a cliff is actually all the way buried right back here. Hard to really show that or quantify that from these kind of images and without being on the ground like the USGS actually is. So those are the aerial images, and one more from the ground over here. And we have a couple of new thermal maps as well. So these maps are showing after episode 21 and episode 23. So, and you can see how in episode 21 we had more of this northern arm of flow along the northern edge of the caldera. Almost always we're seeing them start in the southwest. They flood these nearby areas, make a perched pond which spills over, and sometimes it'll go in all these different directions. What you're seeing here is episode 21. It was almost all to the north, and we have an interesting ooze-up flow over here in the east as well. Episode 23 was largely to the south. It did have one arm to the north as well, right? But largely to the south, and we don't see as much ooze-up flows. Perhaps a little bit here on this in this moat. It's hard to tell exactly what's happening there. But that's the thermal views that we have. And we'll see, I'll just preview now, just jump ahead to, we have a satellite capture of this most recent episode on Kīlauea, also just released from the Sentinel. And you can't really see the shape of the crater exactly through the clouds here, but I can maybe outline it a little bit for you guys. It's something like that, right? Overall, so you can see that we had that southwest vent area, perched zone in the west, and we had overflows that were much shorter this time, but 3 of them. One in the north that was fairly wide, one in the south, and then a central one as well. And so splitting between all 3, and none of them actually made it all the way across the caldera floor, but they stayed stuck here in the west for comparison to what we just had. So, all right, let's show you the S2 camera. This is just the nighttime views of the week leading up to episode 24. So here's a north vent glowing and flaring with brighter and less bright, and then the eruption actually comes. So the south vent might have glowed a little bit. From over here, there's occasional brief little flashes. I'm not sure if we'll pick them up in this speed animation here. Might have been just before the end, but that's how basically how it went. North vent was the more active one with a glow, and it also was the one that was the first to activate and the first to shut off this most recent episode 24. So here we are, the V1 camera, the initial high fountain. You can see it hitting this upper wall up here, and then it's tumbling back down there. You can see this second bench down here as well, and feeding these big flows. And from this angle, we're mostly facing the north vent. The south vent's behind, so only here at the end when the north vent shuts off do we see the south vent actually active. So switching cameras to V2, this is the one that's closer to Volcano House, looking across the caldera east to west. There you see that first ooze out on the crater floor, and then the higher fountains increasing in height. USGS reporting that the first dome fountains and overflows were at 8:55 p.m., followed by the onset of sustained fountaining at 9:15 p.m., followed by an increase in fountains at about around 10:10 p.m., such that by 10:40 p.m. they were at their full height. So V3 camera, there is that first little overflow. North vent only. Here comes the south vent. North vent's really tall. You see there's a back crater wall going much higher over the back wall. It starts coming down after a few hours. As it comes down, the south vent comes up a little bit, still ends up being shorter in the north vent. And you see the massive flow of the active rivers, but also the big, broad spatter and cinder cone here. Is that whole flank of the thing is moving as well. And here we're back to our KP camera, showing that gas injection into the upper atmosphere once again. Let this loop around one more time and see what else we can see here. And that initial glow bubbling and leaking out from the V1 camera here. See that initial V-shaped fountain as well. So something with the geometry of the opening there. Maybe it was a little bit tighter in, or some kind of blockage to cause it to spray like that. And that spray in this view showing like that V. And some of the other angles we see kind of coming across the screen and landing and feeding new flows on that side of the hill, depending on where that spray happens to be landing. So yeah, there's that V again, lower spray from the south vent down here. And you see inclined in that same direction to the southwest there. And there is our uppermost perched pond area. Our second one over here, camera gets blurry because of the fog comes through, maybe dampens the lens. And yep, now we're in full wide out view on that V2 camera. So, all right, those are the views. We've gone through them from that angle. So what else can we tell you and show you? This is the Mauna Loa camera. So back here is the Kīlauea eruption. This is the full width of this camera view. So when we're trying to estimate how high did those clouds go, it's hard because it's dark here at night. But remember, this camera is at about 14,000 feet elevation just underneath. And that's about the eye level here. And it does appear, if you look closely, maybe the clouds are coming up a little bit higher than the perspective that we see here. But that's one of the clues to look for here. Similar from Mauna Kea. It was a clear night, and so let's play this. Over here in this part of the image, off in the distance. Let's zoom it in. We can't really get a cloud height from that so much, but interesting to see how you could see that eruption from all the way in that mountain as well. So just since the concern now has been more of this injection of gas into the atmosphere, the USGS is issuing their volcanic alert notices and aviation notices. They did that, we'll see here shortly after a break, they did that both at the start of precursor activity and at the start of fountaining and at the end of fountaining, that they're really focusing more on this aviation hazard. And so we'll keep checking his cameras as well along those lines. Okay, so here's our S2 camera of that full eruption. And just to show once again, similar to that V3 view, but similar there, you can see the flow of material down here, especially. And I think it's interesting to note like how much of this wall of the cone is buried and exposed. You can see it's actually growing and adding a lot of material into this corner of the crater back here. What might it have looked like for people who are visiting? Here is the K2 camera. Here's visitors to the new Uikahuna overlook down in here. There's the lights paving the path. Restrooms back over here. So down there is that most recent fountain and people coming to enjoy it in that historic viewing area that's been reopened. Happening there, yeah, at night. Doesn't look too busy. Looks like it might have been a good one to go and see. Different point of view. Here's the camera from the volcano house itself, National Park feed. So here we are at night, and those first overflows, spray of lava, fountains crossing the crater floor. And it's greatly sped up, and then you can see the fog from the rain that we had last night and this morning up on the rainy side of Kīlauea here. Still, there was, for those who were there and able to see it, you see lots of posts on Hawaii Tracker Facebook group. Lots of great images to see there. Okay, so we'll come to the B1 camera next. Now the B1 camera here is really zoomed in. Let's get this out a little bit. All right, so this is the last 24-hour GIF from the USGS. And I'm just showing this because, unfortunately, this image that shows us typically the widest view of the crater after 2,000 hours last night seems to go offline until this morning, right after sunrise, 8:40 a.m. So this camera is actually not catching the eruption itself, but it is capturing the before and after of it. So to make it a little bit more useful than this, I thought we could show you guys this version here, which all I've done now is just put together the image from noon on this camera today and then one from yesterday. So just two images, just 24 hours difference in these two, just so you can see what the changes actually are going on here. So I'll probably have to zoom it in for you to see what's really going on. Let's start back near the source here. And you can see the vent area itself, and this whole near field kind of in here seems to have a lot of change because of new flows covering much of this area. You see that this edge of the perch pond, that remains there as well, but see lava has flooded over it and made a new flow that comes something like this, right in this direction over here. There's also, if I come here more towards the center, you see this patch of sulfur deposit material that was there yesterday at noon and today has been covered. So then you can somewhat trace out here. There's another arm in the middle of here as well that led out from this. And then also in the back, you can see there's another arm back in here, something like this as well. And that corresponds to those three branches that we saw before from the satellite view, the Sentinel right there from above, the northern, central, and southern branches right there. So that's the best we can do when we only have these before and after views, and some places in the world, that's all you get. You can kind of see here how we're filling areas from lava flow accumulation, like right in there, for example. But there's also places, let me come further over here to the right. And you see actually that flow seems to come all the way to in here, perhaps. And maybe that satellite view didn't quite capture the full extent of the lava flow, but you can see here this northern branch seems to have gone a little bit further all the way to here. But also we can come to areas like right in here and look at this patch, this block of lava right in here. Right there, that whole thing. You can see clearly it's rising upwards. This is just from yesterday to today. So clearly the lava injected underneath the surface of the crater all the way over here too, right? And all the way to this edge, showing it's adding material not only above ground, but also by injecting it beneath this crust too. It's spreading a larger area. That makes the volume calculations a little bit difficult. You really have to come and scan everything and see where everything has been uplifted and not just see what's come out of the vents and come across the top. So another thing we can see here, besides it's foggier and Mauna Loa seems to come in and out of view here. But what we really want to point out is this changing profile of the caldera rim here and back, I've referred to a couple of times already. So the USGS is referring to this new hill that was there after episode 23. That seems to be this one right here. The one that I'm tracing out from the before image, actually, right there, something like that. And so before that, this bump wasn't there either. So you can see the higher fountains dropping material outside of the caldera on the upper rim. Out of this hill last episode, and this time, 24, you can see this new hill appearing, disappearing right over here in this closer part of the horizon. And really fascinating to see that change in there. And I'll pull it back now. And it's harder to tell. It's a lot easier when it's nighttime. You can see everything glowing in the dark. But when we have to, we can analyze images in this manner like this to pick out the impacts of each episode. So looking now just at what's happening currently, live view at the V3 camera. Pretty quiet there, still degassing, recovering from the last episode. The V2 camera is supposed to load. There it is, the V2 camera. And a V1 camera here, just before sunset on Kīlauea. All right, so that'll be the first part of our broadcast here. I'll pass it to Dan and Lou to do our community corner. And we'll come back and do our volcano watch and monitoring segments.
Right. Thank you, Phil. Let's go ahead and bring in Lou. How you doing there, Lou?
Hey, I'm good. How we doing?
All right, there you go. You are on screen.
There we go. See if we can get that to work. All right. Well, that was something. What's going on? So, some of the cams, some of the instruments went down last night. Didn't come on till this morning. The place must be shaking up there.
It looked really windy to me.
Mm-hmm. That's what I thought too. All right, let's head into this community corner, shall we?
Yeah.
All right. We know that it's busy and there's closures, and the park has not really stopped. This has probably been the busiest that we've seen the park in a lot of years. The viewing area that Phil was just talking about, the Waikahuna, the new overlook area that's been there for a very long time. The Jagger Museum was there. The bathrooms are still not open yet, though. They'll be coming soon, but it's an epic place to watch. And Philip was putting up the time lapse of that camera, and we watched that also a lot. And definitely, I was surprised at the lack of people there. There weren't really a lot of people up there. As I think that's probably one of the most epic spots to view this eruption or any episode up there. So I hope you guys get up there and check it out, and drop the pictures into Hawaii Tracker for us. We'd love to see them from up there. There's another shot of the.
Yeah, we did. Somebody, I don't remember where it was, but I did get asked the distance between Waikahuna and basically this where the not the eruption, but where that floor is, and looks like, what is this? Roughly 1,000 meters, so a little over 3,000 feet in that ballpark range. So
over half a mile.
Yeah,
from the vent.
Yeah.
Mm-hmm. It's still pretty close.
That's so. I mean, we saw some footage from there last night that was so impressive. I showed you it earlier.
Mm-hmm.
Great.
So that's
view.
definitely the closest that you could get to the lava.
You could feel the heat, I was told.
Yeah.
From the
there
lava.
we go.
There you go.
That's incredible. So there it is. If you don't know where it's at, just drive through the main gate and head all the way up. You can't miss it because the road ends at the top there at the summit. Dress warm, especially if it's windy and at night. And if you'd like to make a little bit more of an adventure, you can park in the new Kīlauea Military Camp Welcome Center parking area. It's back behind the new HVO building that's being built. There's the Welcome Center. Get all your information there on the eruption and find out what's going on out there. And there's a nice new map that I pulled for us. Take a look at that. The Kīlauea Visitor Center is still under construction and will be for some time now. There's no bathrooms, no water, but there is parking there. So you could park there, walk over to Volcano House. If you wanted to walk out to Waldron's Ledge, you can walk through the sulfur banks there or up to Steeman Bluffs. If there's parking, just be patient, go slow. Somebody's always leaving. So if you just go slow, circle back around, you'll find a spot. This is a nice little, just quick update. You can screenshot this if you'd like. I'm not going to read everything through there, just what's going on, and everything's ongoing. The big thing is the construction going through the gate. It's going to give you the bypass to the reconstruction area for the visitor center. if you go in during regular park hours, meaning like after 9 a.m., you're going to get directed through this bypass most likely, and that means you can't make a left-hand turn to Chain of Craters. You're going to have to go up and around if you're going to want to go to Chain of Craters Road and go to Thurston Lava Tube or Keanake Koi Overlook, Devastation Trail. So just know that if you hit the bypass, you're just going to have to make a circle, a loop around. Life on the Edge is the only activity that's going on in the park, but they have several going on throughout the day. And in between episodes, if you have the time, definitely check it out. The Tsunami Museum has something going on. The first Saturday of the month is here. Free admission for Hawaii residents. Live music by Kanoa Fong. Dane, are we in for some face painting this weekend?
I think we're always in for face painting.
Come on.
Even when there's not an event going on.
Philip's on summer break now, so he has no excuse. We're bringing him with us.
I actually got a prior down at Poiki. I'm going to be doing.
No, I'll be with you for that too. So we're good. We're going for the face painting. Kid-friendly summer talk series is going on June 7th, 10 a.m. to 2 p.m. at the Tsunami Museum, downtown Hilo. Also, the Hawaii Keiki Museum has Island Explorers happening June 9th through the 13th. I really like the Hawaii Keiki Museum's programs. I don't think that enough information about what's going on for the kids gets out there. So you guys see me throw this up quite often, what they have going on. It's over in Waikoloa. It's June 9th through the 13th. Check them out. Give them a call. Find out what programs are going on. I think the next one also is if you have a kid that's interested in electronics, they're building Game Boys, I think, coming up here soon. So it's kind of cool. And our Eruption emails keep going out. If you are interested in being notified for the next episode, go ahead and sign up for our email. If you'd also like our newsletter and what we've been up to for the past month or what we're coming up with for the month ahead, go ahead and sign up for our newsletter here. And we will
for what that email is currently with the episodes. If you're wondering, like, should I head out or not? Is it the start of this main fountain phase? That's what we do, and that's what we sent out last night, just as the fountaining was starting to get underway, to be like, if you want to go and you want to see it, now's the time.
Yeah, and we're getting pretty good on giving you a little heads up before the traffic gets busy, because you only have about an hour, and then depending on what time of the day it is, you're scratching your way through. So sign up for our email list, please. hveri.org/subscribe. And our survey, our 2025 impact survey, is now out there. Hopefully you guys seen the new video that we put up. The link is in that short. I'll also drop it into our chat today, so you can sign up. You're a Hawaii Island local if you live on Kīlauea or Mauna Loa. This will definitely help us out. Helps our community organization learn more about how you engage with volcano updates and social media, primarily with Kīlauea and Mauna Loa. And your input does make a difference. Dane, you want to say anything about that real quick?
Yeah, definitely just anything we can get from especially people on island, but we're pushing this out to anybody that has ears to what we're doing to, evaluate it. And every year this really goes into helping us, document things, which are the people that help fund us like to see. So anything we can get in terms of these surveys really helps out a lot.
Only takes a few minutes. And Dane, I'll keep going. There is the Pohoiki area that's happening.
Yeah. Let me go ahead. Yeah, so this is the blessing is starting on June 9th at 9 a.m. And then from there we'll get the area ready to go, and then the machine work begins. But I found out today that the first stage, and probably why this machinery is positioned as it is with these types of equipment, is because they're going to be making that storage pad up on the new lava flow as the first step of this process. So then when they go in and start removing materials, all the sediment from inside the bay, they have somewhere to put it. So yeah, there is a lot out there, and this channel is supposed to be 300 feet wide at its mouth and reduced down to the old entrance to the boat ramp. So we will see how she goes, but definitely it's been a long time in the making to get something to happen down there.
Sure has. And if you're not familiar with this area and what they're going to be doing, the boat ramp is back on the other side there and to the right of this picture where these people are over here. And they're going to carve out this area through here to allow boat access back to the ramp. It's a pretty big task. And this is an amazing part of the island with a lot of water moving. So this is going to be fun to watch. And we've been waiting, right? A couple of years now. Yep. So good on them for making progress.
It's happening Monday morning down at Pohoiki.
All right.
Well, yeah, we wanted to shout out everybody that helps, make this possible, including the Kīlauea Recovery Puna Strong program, as well as the VIVI grants from the County Council and everything they do to help with this program, as well as our other programs, including the Hawaii Community Foundation and their assistance in this whole process. So we'd like to thank them, as well as everybody that tuned in today, the likes, subscriptions, the shares, all of the comments, all that stuff definitely helps in the background on the algorithm. I know everybody talks about it, but they do because it's true. And yeah, we appreciate you for being here and going through this recap of the last night's eruption with us, and everybody that has made donations, including we had Philip come through with $20. We had Mark come through with a $50 donation, Norm with a $10 super chat, and then Ed coming through with a $50 donation as well. Appreciate that one. And finally, Dawn here with our Pizza Friday $20 donation. Says this one's for Lou this week for all the hard work he does. Appreciate you, Lou.
And now, Dane, did you happen to notice I took off all the extra numbers for you tonight?
Oh, but yes, thank you.
You're welcome.
It was so much. And we do take donations and through super chats on YouTube. However, we encourage people to go over to the hveri.org/donate to if you are so inclined. And we are a 501c3 community-based organization. That means everything is tax deductible when the tax man comes around. All right. Well, thank you, Lou. I think we're good. And I'll go ahead and get Phil back in here for the next part of this recap. All right. And then welcome back, Phil. Oh, you are muted. There we go.
All right, mahalo. Yeah, so it was great to hear, and interested to hear the development of Pohoiki and all the other events. We'll look forward to sharing what we can with you guys on that. I thought I would just pop back here real quick on this image of the V1 camera. Look at our observations here. And so this image is back from March 20th. Now this was episode, episode 14. And I just want to show you guys before our high fountains what we had here on what the profile looked like of this right side of the crater wall right there. And so that's how it used to look. And now let me put our live view of a V1 camera right now, so you can see this big new hill that's in that area right there. That's what we've been talking about, is that big new feature in the landscape. Maybe I can zoom it in a little bit more so you can see it easily there. And let's zoom in this one too, so you can see that it's not there, right? You can see the horizon goes straight across and the foreground slopes down a little bit here, but yeah, a lot of new material. It's starting to resemble a little bit of the Upuai area at Kīlauea, where we have cinder cone that's built on top of the edge of the crater. That Kīlauea obviously had high fountains for a long time as well, and maybe we're now in this phase of high fountains of Kīlauea summit eruption where we're having that same kind of feature. And it's really interesting. It's halfway up here, and the other half of it's growing down here in this little corner, and that's what keeps sliding back down into the main part of the crater floor. So those are some observations there, but among other observations is this week's Volcano Watch, which is what fans the flames observed at volcanic vents. And so USGS is showing here that there have been these orange-yellow flames emanating from both vents in Halemaʻumaʻu. that they seem to be more prevalent just before the fountaining phase begins. And they note that there have been other times of vents observed. In fact, back to Thomas Jagger in the 1900s, observing flames inside Halemaʻumaʻu, as well as Mauna Ulu eruption in 1969 to 74, as well as the Lower East Rift eruption in 2018, as well as 86 to 2018 Pu'o'o era, etc. Right, so a lot of that is something that we've talked about for some time. And nice that they index it all together in one place here. They note here, hydrogen gas is a minor constituent of volcanic gases. Water, which is made of hydrogen and oxygen, is a major component of those gases. But in oxygen-poor magmas, some hydrogen that might otherwise be part of the water remains as hydrogen itself in very small amounts. So then you have your combustible gas there. How can we get the flames? Well, the temperature depends on the concentration of hydrogen within the air. Generally, the higher the concentration of hydrogen present, the lower the temperature required for ignition. So for example, the Hindenburg that had a high concentration of hydrogen was able to be sparked at atmospheric temperature near the ground at ambient pressure. And obviously that caught fire and exploded, as everyone knows. However, when we have low concentrations, less than 2%, like you have in and near volcanic vents, you'd have higher temperatures, typically above 1380 Fahrenheit or 750 Celsius, which is fine because Kīlauea's vents have much more than that, up to 1000 Celsius, 1830 Fahrenheit. But beyond that, we don't see hydrogen all the time everywhere. So what else is going on? This is the newest piece of information that I've seen here in this storyline. They believe another key player for it to be efficiently ignited is the vent geometry. In most cases, flames are observed emanating from a hornito or a small spatter cone within the vent. In this sort of geometry, water-rich magmatic gas can accumulate inside the orifice and stay in an oxygen-poor state because it is not yet mixed with the oxygen-rich ambient atmosphere. So it's kind of stuck in this little pocket and it's not mixing with the greater atmosphere. Allows it to have this effect to then essentially have a super hot nozzle that induces the combustion of hydrogen, creating the flames out of the nozzle tip right there. So that's how you get those yellow-orange flames. This article also goes on to recap the blue flames, like the ones we saw in 2018, from which this image is taken. That is different. That is a result of the vegetation itself. So lava flows themselves don't typically emit flames. Their broad surfaces disperse any remaining gases quickly, and temperatures are too low to ignite any further diluted levels of gas at the surface of the flow. Right? You might have like little exceptions like here and there, but it's pretty rare. Blue flames that are sometimes seen around flows are more likely to be caused by the burning of methane gas, which is produced by the cooking of vegetation beneath lava flow. This was common observation during 2018 Lower East Rift in Leilani. And although these dancing blue methane flames may seem beautiful, they're dangerous themselves and can even create a secondary danger. Because as methane gets trapped beneath the flow, the methane may not just burn, it may explode in and around the flows in vegetated areas. So that constant reminder that those in close proximity to a flow and extreme caution must be maintained.
Right.
So what
those cracks make for the most photogenic ones, but you remember like out in the jungle, you just see the blue flame just like through the gaps in the vegetation, and people, what about that? It's like, don't worry about it. Like, don't go out there.
Yeah. We have bigger problems right now. Was usually usually how it went, right? Yeah, that's not great, not of a concern, but it's not as bad as that giant flow right around the corner. It's causing this to be a secondary effect, right? For sure. So one interesting thing that this brings up, right? We're really zoomed into a lot of these images, and it's hard to really know the size of these things. But they've described how maybe this pit might be maybe 20 yards across, right? So you're looking at maybe like a 5-yard flame or something like that, right? At least a yard or more wide. So it's a big area, and you can imagine that if you were able to somewhat approach like a pool era days when people were walking up to the vents and looking in and looking around at trying to measure the gases coming out, that when you have that big of a concentration, that big an area, it may actually be hazardous to people as well. So that's something, you know, that maybe might be obvious to say, like, you shouldn't be going near there because of the giant fountain of lava. But even the in-between time was an extra hazard to be concerned with. That if we think back to the pool days when people were walking right in there and sticking the gas monitor tube right down the hole, right? That's maybe not the best idea for 2025 here when we're seeing this kind of action. Be interesting to look into that further for pool and what they came up with out of that as well. So that's one more observation. We haven't discussed that much. These flames at the vents that have been there consistently, but as you can see, they are. So let's move on to our monitoring segment here, and let's recap the sequence of volcano updates and alerts from the USGS. So to start off with, we'll come to the daily update on Tuesday, which was issued in the morning at just before 9 a.m. At that point, they noted that the eruption was paused. They were seeing glow at night, intermittent spatter. And so this was their first report of early stages of the phase, the precursory activity here on Tuesday morning. So they note then on, let's see here, the time issued. It's going to be in UTC and not in Hawaiian time. Listen. So here's a volcano notice for aviation, which was paired with the volcanic activity notice here. And here you can see it was issued Tuesday, June 3rd, 12:30, 6 p.m. Hawaiian time. They note that precursory activity had begun earlier that morning of June 3rd, and they're expecting the episode to start. That's really most of it there, just to note that they actually issued for the first time this paired VAN/VONA, VAN-VONA pair for the precursory activity. And then the second pair comes through on a Wednesday. Actually, we get the Wednesday daily update first, coming through at 9:20 a.m., where they note the beginning of the precursory activity the previous day. And then we have the notice for aviation with a VONA, noting the beginning of episode 24 at 8:55 p.m., right? Preceded by spatter gas pistoning hydrogen flames on a morning of June 3rd. Low dome fountaining just before 9 p.m. that put lava flows in the crater floor. Sustained fountains less than 100 feet or 30 meters around 9:15. That increased around 10:10 p.m. to 100 meters or 325 feet. By 10:40, reaching over 980 feet, 300 meters. Additionally, the fountain generated plume that reached 16,500 feet, 5,000 meters above ground level by 10:50 p.m. and increasing. So we have not got a final number of this yet. We saw last week's updates that that number grew and grew with each publication. So maybe that we come back next week and update this number to something greater than we saw here. Right, 16,500 is that little bit above eye level that we saw from Mauna Loa camera. So yeah, that was the VONA, and paired with the VAN with essentially the same information right here. Got the fountaining onset. And then we have that third pairing of them that was issued in a early morning this morning, 5:37 a.m. Thursday, June 5th, noting the abrupt end of episode 24 at 4:28 a.m. Stopping at the north vent first at 4:08 a.m. and at the south vent at 4:28 a.m. So they noted there no other changes anywhere else, and you can see here all the rest of these notices. There's a summary of different kinds of hazards, hazard analysis down in here as well, things that we summarize for you guys as well as part of our updates. So most recently, the update today was this morning's daily update, recapping much of that same information, noting their VAN-VONA protocol that is currently in place now, recapping that sequence we just shared with you guys as well, noting that emissions were estimated between 50,000 and 75,000 tons per day. That's just a general range we've seen during the episodes. They probably could not measure it so easily during the night then. But they note about 13 microradians of deflationary tilt at the tilt meter at Wikahuna, similar to what was seen during episode 23. And following the episode, we saw a rapid change from deflation to inflation at the summit, decrease in tremor. Had only recovered 1 microradian in the 5 hours since the end of it, so that was too soon for them to put out any kind of forecast. Additional time needed is what they say here for episode 25. However, given the deflationary tilt during episodes 23 and 24 was similar, we expect a roughly similar pause following episode 24. The pause between episodes 23 and 24 was 10 days. So that's the best we get today, and we'll see how that holds for this next week. That would put it around next weekend, right? So we'll see. We'll have time between now and then, next week's update to give you a closer forecast if we're holding true to this. We'll see how that goes. Probably most interesting to me is that we've actually updated this timeline. Let me make it fit on the screen a little more easily here, but timeline of eruptive episodes, and maybe that's the best compromise here. Some stuff's scrolling over, but episode number on the left, start date, pause date is what we've had before. Episode duration, pause duration we've had before. We saw last week added approximate maximum fountain height. And now we have this week a new column, approximate volume of lava erupted in millions of cubic meters. So this is wonderful. This is what I've been asking for I don't know, 5 months since we started doing this, right? Because we don't have this level of data, and obviously they were swamped with so much information that they're still catching things up. But I'm glad to see them populate this column back through here, so you can see the range of this, right? The first 4 were probably the ones where we're kind of establishing the system, and you have a 9, 9.3, a 4.7, a 13. That was the one that lasted over a month, and a 6.5. And afterwards, you see smaller ones. There's 1, 1.1. Coming to episode 7, we're at 2.9, 4.6, 5.2, 2.5. You're getting a range of them, right? Now we're in the 4s. A recent high of 5.5, going back down to 2.4, back up to 6. So you see it bounces around quite a bit. 5.2, 2.8, 2.4. So most recently, 5.0, following 4.6. Following 3.6, following 3.1, we're actually getting a little bit more lava out for each of the last 5 episodes here, right? And we're doing it in about the same amount of time. So we're pretty efficiently getting this lava out of there, even though the fountains aren't lasting very long. We're getting a lot of lava out in just 7.5 hours, getting out 5 million, right? So pretty cool. And next week we'll bring you some more analysis of these numbers and show you guys in graphic form how this actually stacks up to what we've been seeing. So that's most of what we have for our observations. We'll keep going here. Let's see here. We have the mounts as well besides our regular graphs. So just to show you guys, we have a new image capture here. These are running for 6-day intervals. This one was between May 28th and June 3rd. And this is before episode 24, after 23. And when we look in here, we can see there's broader adjustments, but nothing very major happening. You can see it over here, this area, and this southwest rift we've seen activated with some changes recently, but otherwise very broad numbers, broad colors here, until you get to this very center zone where you see in here what appears to be some uplift in coherent fashion of that crusted crater floor. And so we'll look at that in more detail and I'll zoom in here in a minute, but this is what we have for this most recent 6-day interval. The one prior that goes May 28th back to the 22nd look like this. This was episode 23, where we saw that big fallout zone to the southwest, as well as that hill growing over here in the southwest part. And this more hectic, chaotic area in the center here, showing where the flows are covering the crater floor and where it's moving and inflating and all of that. So that's the one last week. And then a week prior to that, to show you, we had similar action in that shallower southwest rift. Similar fallout on a crater rim. And this one in the middle, we also see some signs of a little bit of coherent inflation. So let's zoom in to those last three as well. So here we have this most recent 6-day period. And usually to see this amount of interference, right? That's what was happening is an area that's outlined by this rainbow pattern like this, something like that, is all rising up together coherently, flat enough that the satellite seeing this is just moving upwards and not as being reorganized and repaved, unlike the rest of it to the left and the right on the image over here, right? And when we look at the actual scale, we see 2.8 centimeters for each color cycle. So if we look, for example, at this dark blue, which is right here in the center, and then we go, there's 1, 2, 3, 4, perhaps, right? So something like 10 centimeters, 12 centimeters, 3-4 inches, we're seeing that whole area uplift in the 4 days. And so there's more evidence that we have lava injecting underneath the crust and rising big parts of it coherently together while everything is erupting at the surface as well. Here is a zoom in of that following, or that previous 2-week period where it's not quite as clear. And then the one 2 weeks before that where we see a smaller area, but also hints of that kind of thing happening. So further evidence of that injection beneath the eastern crater floor there. So that's what we have there for the satellite views. And let's see here. Can't find my last tab here. So let's see if I can pull it back for you guys here. And no, just a second here. Let's put something. All right, just a second in here. Let me figure something out. Here we go. Sure I am. Okay, that'll work. So here's our data signals for the last week. Our tilt showing a little offset of an earthquake a little less than a week ago, about a week ago or so. Nothing major there, but the gradual buildup we've had with the daily variations until the start of the episode last night, and this morning, the end of it, and the resumption and tilt following that similar rate as we saw before. And this is what leads us to believe another episode is coming. Earthquake counts for the last week. It's really zoomed in. There's not a whole lot of change here between 30 and 50. It's all within our background range. And they're actually pretty slow, both in the Pahala zone and in the shallow parts as well. Here is the distribution map of them. A couple of deeper ones under east of Hawaii here. They're a little less usual, but just part of the background as well. There's not a whole lot, to zoom in on here. We'll maybe look at the earthquakes separately in some of these events a little later, but nothing really alarming here or greatly interesting to point out. For the last month, here's our pattern, that same size drop for 23 and 24 with this extended recovery afterwards as well. So that's what we expect. And the green line showing pool tilt meter still deflating, with no action happening in Middle East Rift. No further threat to people there. Same pattern at Sand Hill there. As a summit, it's nice to have two different stations at the summit, just in case one goes wonky sometimes. That's happened recently. So, but everything looks consistent and coherent. And the 1 month earthquake counts still in that same 30 to 50 range there, all within normal background ranges. And showing a little bit more of that normal pattern with variations here in both the bands of the deep feeder zone and the shallower adjustment zone. That includes the south flank too. So for the last 3 months, in perspective, here is 24 compared to 23 was not as big as there's 22, 21, 20, 19, 18 was a similar large event there, but it had a longer buildup. So we're a little bit, while we're over average, we're still not at the maximum recovery time and not at the maximum drop as well. If you look, for example, this one at 16 was quite a bit of a drop that maybe had something to do with 17. being a little funny as well. But overall, it looks like it's doing the same thing once again, popping back up, and looks like the pattern continues. And no signs of it stopping yet, apart from when we look at the length of time. It's getting a little bit shorter as far as our fountain durations, right? We're more efficiently getting out more lava. So that happens with a more mature system, which we know we have since we're at 24 already, 5.5 months into it. So this is probably the more telling graph for earthquake counts here, along with the last year of GPS. The crater stretching out and then adjusting through intrusions or eruptions and dropping back down, but higher rates in between. Those are accompanied by big numbers of earthquakes during those build-up times. But ever since we had the onset of this eruption in late December, earthquake levels have been down and have stayed down with only minor variations. So that's really how long can that last is the question. And it's anyone's guess at this point, right? Lots of variables, and it's hard to say which one is the most important. We can share all of them. One interesting thing is how the crater continues to extend north to south, even as we see other GPS lines of the summit still dropping in elevation. So, for example, here in Byron's Ledge, you're seeing elevation drop, and here as well, the Hua elevation drop. Okay, so at Pu'u'o, at the Middle East Rift, we're seeing a contraction still, a little bit noisier data. Hard to say exactly what this is. We'll just wait and see how it settles out. We know there's a lot of ground cracks in that area, and there's lots of different blocks of land. And usually when you see something that's this chaotic, it usually means something closer to the surface that's more localized is happening there. It's something you try to avoid when you pick your instrument site, but with the ground being so active and dynamic in areas like this, sometimes it just is going to happen at some point. And we saw that in the early days following 2018 when we saw instruments falling in a crater and ground settling. Yeah, it's kind of stabilized since then. But go ahead.
It's kind of a win when they are able just to, keep the equipment from falling in over those spots or from being damaged otherwise. So a little bit of noise, not the end of the world.
Yeah, that's part of the game with all this remote sensing equipment, right? Even the cameras that we have that have been burned by lava recently, it's just that's why you put a camera there, is you can capture all that stuff. It's never a human person in danger. If it gets melted, oh well, there's no family to notify or anything like that. You just get a new camera, right? You'd rather not because they're expensive. But if push comes to shove and you lose one, fire at PGV or what have you, then they're expendable. Right? So yeah, that's really our monitoring signals there. Could share maybe a little bit of extra on the earthquakes here. If we look at the comparison for the last week to the last month shows a little bit more of this pattern we're in. South flank activity, some localized caldera activity, and then a hotspot feeder zone. When you get to the 1 year and 5 years, you can see that how unusual this is. You multiply this by 12 and you do not get that, right? There's other areas that are showing action in these bigger time windows. But I think it's interesting if you look at the cross sections. It's hard to tell these from just 1 week at a time. But let's see here, for example, there's a last week, Pahala depth. Here is the area above Pahala that's adjusting to all that changing pressure deep down with no connection in between here. So it's like, like the skin above it kind of cracking because of something festering really deep down below, more or less, right? Because the pathway actually feeds more this direction and into the screen towards Mauna Loa, and then kind of out of the screen towards Lo'ihi Kīlauea volcano underwater. So with the 1 week, it's harder to see it like this, but let's come to the 1 year or 1 month first of all. In the 1 month, you can clearly see this sill-like body down under Pahala, right in there. You see a little bit of the connection, but not quite so well. But we come back to just the last year, right? Remember, this is all just 2024 to 2025, June to June. Here, you can see this effect of how much earthquakes are triggered at that hotspot feeder zone. More clearly, can you see this pathway that seems to slope shallower towards Kīlauea? That's thought to be maybe one of these pathways, right? You see earthquakes that accumulate above there, and you can see a little bit of the shape of the island. of this body that kind of gets deeper in the middle and it gets thinner towards the shoreline. And you see adjustment. This is what we mean by the background events. They fill in every bit of that area, right? Here's 1 year, and let's go back to, if I go to 5 years, you can really see like everywhere earthquakes happen. This is all post 2018. This is in 2020. You really see the shape of the island and how much we have it constantly adjusting and shaking and cracking and all that. And so that's what when we say, oh, those earthquakes are background, that's they fit within this pattern of they're just filling in holes over the course of a year or 5 years that in any 1 week period look more like that. Right? So when we see different clusters, that's when we look for something a little different there. So let's just wrap it up here with our recent earthquakes. Here is the map for the last week on Kīlauea, colored by depth. So similar to what we're just looking at, but island-wide. And you can see there are some deeper events under Mauna Kea and East Hawaii here, 2.4 and another 2.8, 16 miles down, and this one is 22 miles down. There's our Kīlauea events, the blue ones over here at Pahala. We have one shallow event up here, basically at surface level, 2.3 is what this is showing here in this upper southwest rift of Mauna Loa. One earthquake by itself is not cause for alarm. It's likely something cracked or adjusted, but it's not a sign of some giant outpouring to come. It's more a sign of some minor localized adjustments, settling, cracking, that kind of thing. That's normal for the ground to do. A little bit of clustering of events over here on the west flank. This west flank does move. It's interesting to see that. It's not doing it very fast. It's kind of at that background rates over there as well. Similar to Kīlauea moving south. Over here, you have some action over there too. And there are some shallower events over here. So 1.9, 4 miles down in this northwest quadrant, and a shallower one also a little more to the north. These ones are a little interesting. We saw this area. We haven't seen very many recently here, but this zone was the one that when a magma chamber began to get full, it started to activate earthquakes in this area more often. So just one by itself, same thing, might have been localized in time and space, adjustment, settling, but one thing to look for in the future, as we're anticipating Mauna Loa refilling and at some point showing more signs of that filling, might one of those signs be increased earthquakes in this sector over here northwest. So nothing quite yet, just this is still the prequel, but just pointing that out, we can keep an eye on that on the years to come here. So that's the earthquake map. We always look at it this way as well, sorted largest one being 2.8 under Mauna Kea, 2.8 under Pahala, both very deep. The next one, 2.7 underneath Kilauea Summit up here. Yeah, these are all colored by time, so these are all within the last week, but not within the last couple hours. Or in all but one case, not within the last day either. So that is the earthquake distribution here, and that wraps it up for me, Dane. Pass it back to you.
All right, good. Well, yeah, we do have some questions in the chat. If you want to go ahead and try on some of those, let's go ahead and start with Buster Brown says, I have a question. Is it possible that the earthquake under the caldera that looked to be on a ring fault affected the system and caused the prolonged repose before the start of episode 24?
Yeah, it's a great question. I think that's possible. But then, why might you have an earthquake on that ring fault? I mean, it might just be the actual injection of lava underneath that upper crust of the crater, and then the edge of it actually popping up too. That can be something that could be producing an earthquake signal. So I'm not sure if we can trace a location to that precision necessarily, that it's call it necessarily right there. But yeah, whether that's something that affected to the injection of the crust, or if somehow it opens more space down there as well, that could also be something that increases the reservoir. That would take it longer to fill. But other factors would be, how much did it empty? How fast is it refilling? Those kind of things. So it's not the only factor, Buster, but it is a good point that there could be effects of other movements of the ground around there, producing earthquakes and changing the reservoir geometry shape, causing it to take longer to pressurize, for sure.
All right. So next we have, I'll go ahead and toss it over to Red Rover, who asks,
This is, I feel like, a good understanding question. Are there two separate reservoirs supplying each vent? If so, do we know if it's the same lava?
Everything we've seen, it's a great question from Red Rover. Everything we've seen is that it's all the same lava coming out of essentially a split nozzle, right? And there are times where we see both vents active. One vent active, sometimes recently it's been more often the north vent, but in the past it's been only the south vent as well. Could go either way. And there is maybe some variation of the lavas erupted from episode to episode, but I don't think that we have been able to differentiate from vent to vent necessarily, because they're kind of mixing with each other right in there. But what we saw is how they actually began as a fissure that cut across and had more openings than just those two. And almost all the other ones got blocked off, except these two stayed open. And so we do believe that they're essentially like connected as a blade, right? It's the same analogy we used in 2018, or like a blade that has different fingers that come up, and each finger is a different exit point, right? And so they're not necessarily just straight fingers. It could be kind of curled or have little S jogs or funny things that make it difficult for the gas to come up so easily, for the lava to shoot up so easily. And they can change between eruptions. This is something we've been discussing in the past. And I forgot to bring that Honolulu picture again, Dane, of those guys standing in there. But
I mean, it's burned into my head when I saw it. It was like, dang, they just sent it back then those days, type of thing. Like, oh, well, we think we'll be good. Let's just go. And then they go. It's pretty cool.
Yeah.
So yeah, the old days of cowboy volcanology. I think Phil's looking for it right now, so I'll just continue on. But yeah,
I can't find it. Yeah.
No,
not quite yet.
Not quite yet. So we have a question here from Mark. If you're ready to move on.
Yeah.
All right. Mark asks, when the USGS provides lava volume estimates, are they including the tephra and other volcanic particulates? Or is it just the flow?
That's a great question.
Like a relevant question now with how much tephra is getting, forming a mountain behind this thing or a hill.
Yeah. I don't know in particular for this eruption. That's a great thing for us to ask them when we have a chance. But I would imagine that they are also concerned with this, and they are likely going to want to include the tephra as well, for sure. Maybe there wasn't enough for them to be measuring it before, but like now you can see they're actually actively trying to measure it, and part of that is trying to get some volume that they can add to it as well, right? I think it's similar when they're doing their drone flights to create their new structure from motion models that have new elevation of the ground surface. They can keep scanning that crater rim as well and get elevation change that way too. And so I imagine that they are doing that, or they will be doing that if they haven't done it as much yet. Don't know the specifics, but yeah, for sure it's something to be concerned about. Clearly it's a lot less that's landing in the upper rim than is going into the crater itself. And then you have what I've been mentioning, lava injecting underneath the crust. And if you don't rescan that crust also, even though it hasn't been covered, you don't add in what's been injected beneath it to pop it up. And so there's that always going on. And then you add to it that there's always gas coming out of this stuff that's leaking out. And so it's losing volume while it's gaining volume, and it's getting injected. And that makes it all very, very tricky to really get real numbers. Yeah. So even with the numbers USGS gives, and with a new table we're going to put out for next week, and the maps that they have, there's still discrepancies because of that. It just things change in between, and it depends how much you're counting. Yeah. So there is some error, and that amount of error I would say might include the amount of tephra that's landing outside of the crater too at this point.
All right. Next one is from Mika over on Facebook asks, and we're not doctors here, but I've been feeling nauseous. I'm in Fern Forest. Would you say the gases are strong enough to cause this nausea? Now you're in that area, Phil. So how's been the gas?
Yeah, I have not myself at my location had any impact of the gases this time around. I suppose it's possible that there could be something more localized. But if just myself, I can't say that I've seen it around here.
But it was more or less like on the other episodes for you.
Yeah, well, yeah. I think really these last couple have been even less impactful, right? I've heard, we've heard less
The
about
winds,
Achilles hair
yeah.
falling in Volcano Valley. The winds have been more favorable, and the time of day, perhaps, or it just hasn't. Yeah. So yeah, like being said, I'm not a doctor, and if you have a sensitivity, and maybe that lower concentration maybe affects you and doesn't affect me as much.
Right.
Hard to say, right?
And just living around the 2018 site, I will say that the SO2 and the particulate matter impacts different people differently. There's people that I essentially just said that you're just sensitive to it. Like, I will go to the same spot as you and won't feel anything, but they have, almost allergic reactions, it feels like. And also that you can get these deposits of gas in all these different little areas. So it's like, you might not have gas in one spot, and then you walk a little bit further and then you smell it, type of thing, or so it can be weird. All
Here,
right.
I found it.
Yay. Yeah, that crazy photo.
So yeah, this is between episodes at Mauna Ulu, right? And they actually have twin vents. This is one right here, and the other one is over here. And here they have this little division in between them, right? And so kind of see the glow through there, and that's pretty nuts.
Yeah.
So imagining like all this variation in here, right? Like how you have a little opening inside of the crack itself. You can imagine if lava is spraying out of here and it's going to spray out over 1,000 feet, and like one rock sticks in the middle of here, it might really reshape the entire thing, make it V-shaped or change it. Or let's say this chunk falls in and it falls right there and it wedges in that side of the crack. Suddenly your crack's a different shape. So this is the kind of thing I usually hand wave off to, like something funny is happening in there, and a conduit due to the geometry. That's just some little bit of insight of what I might actually, how I imagine the chaos in there to be. It's something like this that was originally one fissure, has some signs of that being the case, but really is localized at two spots, but it's still dealing with all this jaggedness and chaos of geometry down in there.
All right. Well, I got one question about cracks for you. Paul asks, could more cracks in the crater alter the lava output within the two vents? Hence, there could be a new opening within the crater floor.
Sure. Yeah. We haven't seen it as much recently, but there have been times where you've seen little leakages of lava out of the south vent, like the south part of the south vent outside of the throat of it, and the front side, like the east side of the south vent outside the throat of it as well. So that original fissure system, that the crack that we're describing, has other parts that are not all the way connected to the surface still that are active down there. And so, yeah, if you had a reason to make a new crack, that's really the thing, right? We don't have the pressure building enough to like force a new crack, because it just shoots lava out instead of that. So what would actually force a new crack? And that's really the question. Maybe if you like injected a bunch of lava as an intrusion somewhere around the summit, that could cause new cracks and reorganize things as well, and reorganize the geometry of the vents too. But it doesn't need to do that, because it can just go out the vents. So usually once you get to this age of an eruption, you don't really see the change like that, Paul. It can happen, but it doesn't have a good reason to happen right now from this eruption itself. It would need some kind of external force, right? Something create. Let's say a meteor crashes into that part of the vent and makes any. Yeah, sure. Then it can change things too. No, unlikely.
All right. Do one more. Last one from Hotel Papa. I believe this is talking about the glow during the periods of inactivity happening up there. I have a hard time believing that it's just hot gases that can maintain incandescence. Are there exothermic chemical reactions going on with the volcanic gases? Come to mind in contact with air, maybe catalytic with lava. Just looking for those incandescent parts.
Yeah, I think there. Yeah. It's hard to really. I'm not an expert in this either, and it's hard to really understand and explain it, right? But when I see the changes in brightness, to me that's something as well, right? So I think there's something about the gases themselves being hot and incandescent, but it's something where I've seen that more with my eye rather than like on a time-lapse camera where it's not as visible. When I see the glow in views like this, I imagine it's actually the lava column itself is risen in a throat enough where it's the brightness of the lava itself that's illuminating all that stuff, right? So not so much the gases and they're hot and they're glowing, but the actual lava is lighting up the gases because it's so close. We've had reports of the US just flying over in helicopters, and they look down in the daytime and they see the lava down in their throat. And we don't see glow, we don't see any action on the surface besides just gas coming out. But they see that it's down there, and then we see it get brighter and dimmer and brighter and dimmer. And to me, that's the actual column rising and falling. And I mean, this also from the era when we used to hike out to Pu'o'o and like look for the glow from the crater out there, and all with your eyes, right? And there would not always be lava lakes, but just like little skylights or little vents, hornitos as well, with gas jetting spots where you'd hear roaring and you'd see some of this incandescence as well. But it was never that bright like that in my memory. Yeah, Dan.
Yeah, I think they were talking about the incandescent in the wall itself. You remember, like back in Fissure 8, how after it stopped, we had all those glowing points in the wall. You remember that, right? I think that's what
maybe. Yeah. Well, so
I think all that has to do is just like that stuff is really good insulation, huh? And you can see through the cracks and the little holes or the pukas.
The glowing points of, the cone itself is like a mishmash of, it's basically like a combination of solid stuff that's frozen in midair and then all the goo that's still somewhat fluid and hot in there. And that's why even after the eruption is over, we see this hill moving and kind of slumping under its own weight because it's still fluid enough to actually move. So all that stuff is still hot enough that when it's exposed inside, that actual lava can be incandescent also. So I think the question would be more of the gases coming out of the throat of the thing itself.
I think you got both of them now.
Yeah, that's a discussion around those points, and just to note, like the views in these time lapses are, like look, the south vent's glowing, but if you're actually looking at it in person, you'd see way more than just that tiny little thing in there. Like maybe this is the incandescence of the gases kind of level right there, right? And then when you see something more like that, then the lava surface has actually risen up, the gas pistoning up, and then it drops back down, and you see it dim again. Right? But none of that's going to really be picked up on these cameras and the time lapses as easily. It's something that sometimes visually you can see more than we do with cameras. I'll leave it at that.
Right. All right. Good. Well, I think that gets us through everything. Our standard time is 5 p.m. Hawaii Standard Time on Thursdays, and we do go live with something outside of the ordinary that we think people need to know about. So far, at this point, the eruptions are almost coming expected, if they're not expected at this point on that weekly schedule. It's really interesting to tell people like, yeah, we have a 1,000-foot lava fountain. They're just like, oh, again, type of thing.
So yeah, that's great. So yeah, we'll see if we actually get one within the next 7 days before a week from today, or if a week from today we're talking about precursors to episode 25 and still waiting its arrival. And yeah, just keep an eye on our channels until then, where we post updates just about every day with what the USGS is saying, and I hope you guys keep track of that in an efficient way. So appreciate all your support. If you guys have made it through this full hour and a half, you are one of the, let's see here, it looks like at least 80 people dedicated all the way through. So mahalo to all you guys, hardcore guys. So until next week, from the nonprofit HVERI, Hawaiian Volcano Education and Resilience Institute, for Lua Torre and Dane DuPont, I'm Philip Ong. Aloha, everybody.